Hello, we're going to talk about example 6. And example 6 says we have a complex number z1 is 3 CIS pi over 6 and z2 is 5 plus 5i. We're going to express z1 in Cartesian, z of 2 in polar. We're going to multiply those two in Cartesian and polar, hence find the exact values of sine 5 pi over 12, cosine 5 pi over 12, and tangent 5 pi over 12. So that hence means we have to use what we have up here to be able to show these. So first we'll start with z of 2 in Cartesian. So I mean z of 1 in Cartesian. So z of 1 is 3 times. What is the cosine of pi over 6? Well, that's root 3 over 2 plus the sine of pi over 6 is a half I. So I'm going to end up multiplying that, and I get 3 root 3 over 2 plus 3 halves I. So that's z1 in Cartesian. Now, so that's A. Now B asks us to do z of 2 in polar, right? But first, to write that, I'll find the modulus, and that's going to end up being the square root of 25 plus 25, or 2 times 25, which is 5 root 2. And so now I know my my modulus. Now I need my argument, and that's the tan inverse of 5 over 5 is just going to be 1, which is just pi over 4. So z of 2 in polar form is going to be 5 root 2 and CIS of pi over 4. Good. So now I've represented them. I have all the forms for both complex numbers. Now, that's C asks us to calculate z1 times z2 in both polar and Cartesian. So we'll start with Cartesian first. It's a little harder. So z1 times z2. Well, we found z1 to be root 3 over 3. Over 2 plus 3 halves I, and then we know that the other one is 5 plus 5i, right? Good. So I'm going to try to keep things organized here in my real and complex parts, because we know what's going to happen here. So the first one is this times this, so that's going to be 15 root 3 over 2. And the other real part will be this times this. That'll make that a negative 15 halves. That's our real part. And then I'm going to keep our complex parts together, right? So that guy times that guy. Well, we'll do this one times this guy. It's going to be 15 root 3 halves plus this guy is going to be plus 15 halves. And that's going to be our complex part, which is going to be simplified 15 root 3 minus 15 all over 2, and then plus I'm going to have well, I don't need that. Let's write it like this. 15 root 3 plus 15 all over 2, and then I. So that's if I multiplied them in Cartesian form. So they're there. So I'm going to have pi over 6 plus pi over 4, and I'll find a common denominator of 12. So this is going to be 2, 2, and this is going to be 3 and 3, and then I'll have CIS of 5 pi over 12, right? And that's working out. Now, so that's our multiplication. Now, the last thing it had to do, we multiply both in Cartesian and polar, and now hence find what the sine, cosine, and tangent of 5 pi over 12 is. All right. So the way that we're going to do this is I know that from what I've shown right up here, I know that 15 root 2 CIS of 5 pi over 12 is exactly equivalent to, this is my polar form, is equal to my Cartesian form that I have right up here. So that's 15 root 3 minus 15 over 2 plus 15 root 3 plus 15 all over 2I, right? And now to find, I can equate the parts, right? I know CIS, the cosine is going to represent this. Well, I'm going to simplify this first. I can divide this by here, and I can actually get CIS of, that's supposed to be 15, right? Or no, 5 pi over 12, my bad. 5 pi over, that's supposed to be 5 pi over 12. So it's supposed to be 5 pi over 12. And I can see that the 15s are going to cancel. And then I'm going to have a root 2 in the bottom. So it's going to be root 3 minus 1 over 2 root 2 plus root 3 plus 1 over 2 root 2I. And now I can equate the parts real simple. And I can say that the cosine of 5 pi over 12, right, after I rationalize the denominator, root 2 over root 2, it's going to be root 6 minus root 2 over 2, right? And then I can do the sine of 5 pi over 12, right? After I rationalize the denominator, it's root 6 minus root 2 over 2. And then I can do the tangent of 5 pi over 12. And that's going to be that guy over that guy. Or I can write it like this, root 3 plus 1 over 2 root 2 times, if I'm dividing by this, I'm going to take its reciprocal, so it's 2 root 2 over root 3 minus 1. And then finally, those guys cancel. It's just root 3 plus 1 over root 3 minus 1. That's a 3 right there. And that's the tangent of 5 pi over 12. So I equated, well, once I had the two forms, and this is a common problem you'll see in your past paper problems, I equated the polar and the Cartesian, and I was able to find all these, the cosine, the sine, and the tangent of those angles in exact form. There you go, guys. Thanks.